In this video, I'm going to show you how to repair a worn pivot hole so that it's round and back on its original center. And I'm going to do this by hand using a reamer. Hi, welcome to Chris's Clock Repair. The basic procedure is 1, disassembling the movement, and then 2, determining which holes need to be bushed, 3, marking these holes so that you know how to cut them, and then 4, cutting them. And I'm going to show you each of those 4 steps. And if you watched my earlier video, how to repair a worn pivot hole, this video is for you because this step was omitted from that video. And the purpose of this is to fill that gap, as this is one of the most crucial components to good bushing work, because your hole needs to be on its original center in order for the depthing for your wheels and pinions to be correct, and also to ensure that from plate to plate your wheels are upright and centered. So let's do some clock repair. So here I've got an Ergos 32 movement, chain driven grandfather clock movement, which is very common. So if you're doing any amount of clock repair in the field, you will come across this movement pretty regularly. And sometimes they're really worn. This one's not too bad, but traditionally the time train on these clocks, for whatever reason, because of the design, the time train just really gets worn, especially the center bushing. All right, so let's get started by disassembling the front works and the back works of the movement. All right, so now I'm going to demonstrate step 2 of this procedure, which is to mark the worn bushing holes that we're going to repair. And I'm just going to show you how I do this for one of the trains. And I'll do the strike train here to illustrate the point. If you take your ratchet wheel here at the bottom, right, so when it clicks, that's the direction that you would wind up the weight. So you know the weight falls on this side. So down with this wheel would be the drive direction, okay? And because the weight is straight down, the wear on this hole is going to be down. So if you have difficulty seeing the wear, you can use a contact cleaner, a handy dandy quick dry contact cleaner, which is from Home Depot. It's like $6. You can spray this into the hole to help you clean it out, and use a Q-tip, and that'll help you better see the hole with the pivot in there. So what I can do is put a Q-tip back here, put my contact cleaner right there, and just blow it out. And I got the Q-tip on the back side. I might use a toothpick here. Okay, we'll hit it again. And we'll get that cleaned out. All right. So now when I move it, I can really see what's going on with that. So here's the basic procedure. Now that the holes are cleared out and I can better see the wear and the motion of the pivots in the holes. All right. So if I put power on this going down, Well, I know this pivot, the wear is down, and I mark the direction opposite the wear. So I'm going to mark that up. So going up with this wheel would be the direction of opposite power. So that's the direction I mark. Now, looking up the train at the next wheel, the next pivot, all right, what I want to do is I want to watch this pivot as I take my ratchet wheel down here. So I take that wheel and I push down with power and I watch it. And then I go the opposite direction, I watch it. And I look at how much it moves. And I use that as a guide to determine A, the direction of wear. So the direction of wear, in this case, is going this way. Do you see that? It's going this way. Direction of wear, not wear. Wear, not wear. Okay. Now the one, so I'm gonna mark the opposite, the direction opposite the wear, because that's the direction I'll be cutting. Now the hole above it is far more worn and is much easier to see. So now when I move down with the width of the power, it moves the opposite direction, the hole below it. Without power, with power. Without power, with power. So I want to mark the direction opposite the power. Again, because that's the direction I'm going to cut. With power, without. You see that? So I'm going to do this procedure for all the holes that I'm going to bush. Okay, and just for some fun, I want to show you just how badly this ergos movement can get. This is another ergos movement that I was working on just before this one that I was filming for this video, but ended up having to redo it. So check this out. And I mean, this clock is so bad, pretty much everything needs to be bushed almost. I have to show you this one here. Look how bad this one is. Oh my God, look at that. I mean, if you can't see the wear on that one, then you've got an eye problem, not a clock repair problem, okay? So that's the unworn sign, that's the worn sign, all right? Okay, let's get back to work. Okay, so now I'm gonna take the movement back plate off. There we go. From the back plate. All right, so here's my strike train on the back plate, and I'm going to remove these posts so I have even less obstruction. Okay, because this hole was pretty worn, that's the one I'm going to demonstrate doing. This one right here. Okay, and we marked the hole in this direction because that is the direction that the hole is not worn. And if we could look in here closely, I'm going to clean this out a bit more with my cleaner. Okay, you can readily see that there's wear going in the opposite direction of my mark. And there's like two little ridges here. Here and here. Okay, so what we're going to do is we're going to cut this hole so that it becomes round and on the original center, which the center of this side is the original center because that's the side that hasn't worn. So I'm going to do a little drawing here to demonstrate what we're going to do with the reamer. and then I'll demonstrate actually doing it. Alright, so I got a little diagram here for you on my dry erase board. And if you look here, this black hole is the outside ring of your oil sink, and the blue hole is your pivot hole, the original. And that blue crosshair is the location of your original pivot center, and that's where we want our center to stay. But because of this wear here, the center is shifted up and to the right a bit. And you'll see there's these two little ridges that kind of occur, and eventually your pivot will get stuck in the worn area and stop your clock. So what we're going to do is we're going to repair that. And how we do that is, or how I do that, is with a reamer. So if you can imagine, okay, here's a reamer, and it's obviously not large enough for this hole. But what we want to do is we want to insert this reamer such that the cutting edge is on in the worn area, right before that burr. Okay, so it's about here. And we're going to rotate our cutter around, taking off a piece of this blue all the way around until we get to the other side. Essentially, what we're doing is slowly moving our center from this red mark to the blue. And then once we get to the other side, we pull our cutter out and go back to our original starting place and cut a little bit more. And we're going to go around like that until our new hole is at the back of the wear. The back of the wear becomes the back of the outside diameter of the new hole, and we maintain our center. So I'll kind of try to draw that. So we're going to cut a little bit around, and you can use your oil sink as a guide. We'll cut a little bit more. I know this is not the best. Until eventually your cut goes all the way around to the worn area, and now your center is back where you started. And depending on how much wear you have is going to determine how many cuts you have to make, and what size reamer you use depends on the size of the hole. And you might have to start with a smaller reamer, and you don't want to take too much material off at one time because you might break your reamer. All right, so let's demonstrate this procedure with the movement. So this is the wheel that we're going to be bushing, but before we do bushing work, you should always polish all the pivots first. So that's what I'm going to do first. However, this video is not about polishing pivots, so I'm not going to demonstrate that. Okay, so here's my worn hole that we're going to bush, and I've got my direction opposite the wear. So that's the direction I'm going to cut to with my reamer to move the center in that direction. I'm going to use my oil sink as a guide. Okay, it's not a law that the oil sink is perfectly centered, but it's a good guide to make sure that you are staying round and on center. Okay, so I'm going to stick my reamer in the worn side, and I'm going to cut like I showed you on my dry erase board. Okay, so I'm going to use my bushing tool here, my hand bushing tool, and this is my 197 Bergeon reamer. Some people prefer the KWM system, which is perfectly valid, and you can do this procedure just as easily with that. So I'm going to stick this in just a little bit. I could only get a little bit in the worn side, and I'm going to start taking off that burr or the material, and I'm going to go all the way around till I get back to the worn side, and I'm going to pull it out. Okay, so I move my hole a little bit away from the worn side. Okay. And you don't necessarily have to take the cutter out. You can just back it out a bit. You see the material coming off? All right, I'm going to use my other hand tool that doesn't have my knurled nut here, so you can see better. So I've made 2 cuts. And you can sort of, with practice, you can feel when the worn side when you get to the worn side and it doesn't really cut anymore. Right there. I can kind of slide my cutter, back it out. And you can sort of feel the cutter when you've got your hole round again is going to, it's not going to drop down in the worn center area. It's gonna want to cut it because you've now made your hole equal to the size of the edge of the wear. So I'm cutting. I can feel it cutting. And here's my piece of material about to come off. Right. And as you go, you can continue your cut a little bit further. Back my cutter out and pull it out. Now look at my oil sink. I'm now starting to get pretty close to the size of the hole, and I'm increasing the size, how far my cut is. You see that piece of material coming off, okay? And I'm now, the cutter is cutting all the way around, so I know I've got a round hole. It's not dropping into the worn area anymore. And now I know my hole is round and on center. So now I'm going to finish my cut in my drill press to make sure that I was perpendicular. And then we'll see how it looks. Alright, so now looking at the hole after I finished it in the press, you can see that the oil sink is pretty even all the way around. My hole is straight and is now centered because I moved the hole with my reamer by hand before cutting in the drill press. Alright, so now I'm ready to size the hole for my bush. And I just cut that with the 197, so it's actually already ready for my bush. I'm going to chamfer the burr created from my reamer and then press my bush in from the inside of the plate so it's flat on the outside, and then I'll cut my bushing down. I'm going to use my block and my pusher push my bushing in from the inside of the plate. It sits in there nicely because of the chamfer. Okay, so here I've got my bushing. It's proud to the plate, so I'm going to cut it down. They call these pivot cutters or rose cutters. It essentially cuts down your bushing. It has a pilot pin that sticks out to guide your cutter in the bushing hole. And there we have it. So now we just have to size the inner diameter for the wheel. So that concludes the purpose of this video. And I'm going to show you before I did the work and the hole as I cut it afterwards before I inserted the bushing. And then after I finished the bushing, sized it, and installed the pivot. So I used a 5-sided cutting broach to size the hole, and then I finished it off with a smoothing broach. And then we're going to repeat that procedure for every worn pivot hole in the clock. And then you'd finish the bushing work off by cleaning the movement. So try this out. Let me know how it goes. As a note, on very small pivots like those you see in a French clock, if you have to do the third wheel in a French clock, for example, the reamer is not going to be very effective because you can't get it into the hole. So what I'll do is use a very small 5-sided cutting broach, and I'll hold my French plate, for example, in a vise with cardboard to protect it, and I'll use my thumb on the back side of the broach, and I'll use my downward pressure on both the front and back part of the plate in the direction opposite of the wear, and I'll cut left and right on both sides of the movement so that I can cut away on the unworn side just as much as there is cut on the worn side, and then I'll ream it out with my reamer afterwards. And that's basically the same procedure one would use if they're using a needle file, which is described in the following book that I'd like to show you. I highly recommend picking up a copy of and reading Clock Repair Basics by Conover, which is excellent for a beginner, but also really refines your know-how as a more professional repairman as well. But in that book, he has a great chapter on bushing work, and he uses KWM style system, and he uses a needle file to round the holes and find them on center. There's some great diagrams in there, and I suggest you get a copy. And thanks a lot, Steve, for letting me feature your book in my video. All right, Bye for now.